In our last class, we discussed about derivation of lightly loaded bearing as well as Reynolds two-dimensional equation. So today's class, based on those equations, we are going to solve some of the important problems. Okay, based on those equations, lightly loaded bearing, uh, in that a frictional force as well as torque and power loss. So based on those equations, we're going to solve some of the important problems. Okay. First problem, uh, just take the first problem. So it is a full journal bearing as the following specification, a full journal bearing as the following specification, shaft diameter 46 mm, shaft diameter 46 mm, bearing length 66 mm, bearing length 66 mm, radial clearance to the radius, radial clearance to the radius, it is 0.0015, speed of the journal 2800, which is in RPM, radial load on the journal 82 kg, it is in terms of kgf, that you have to convert to Newton by multiplying 9.81, so that it will convert kg to Newton. Viscosity of the lubricant at the operating temperature, viscosity of the lubricant at the operating temperature 8.4 centipoise. Consider the bearing as lightly loaded bearing, means it is belongs to lightly loaded bearing. So determine first one frictional torque on the journal, second one coefficient of friction under the given condition small f, and the third one power loss, that is P in the bearing. Okay, so this is what the actual picture, a journal and the bearing. Okay, this is a journal. Here you can see this is a bearing. Okay, so this is a bearing and this surface is called journal, and this is the length of the journal, and clearance between the journal and the bearing, there is a radial clearance, and this is the diameter of the journal, and radial load acting on the journal or bearing. Okay, so based on these data, you have to find out the frictional torque as well as coefficient of friction and power loss. First, you have to write on the one side what are the data given. Here, you have to write on data. First, they give that is 82 kg, that you have to convert to 82 into 9.81, that gives in terms of Newton it is 8 approximately. You can take it as approximately, you can take it as 820 Newton. First data. Second, they given the diameter D. Diameter is 46 mm, that you have to convert to meter, 0.046 meter. So we need a radius. So 46 divided by 2, that is 0.23023 meter. Similarly, their given length 66 mm, that is in terms of 0.066 m, and viscosity they given mu is equal to 8.4 centipoise, that is 8.4 into 10 raised to minus 3 Pascal second, that you have to convert to SI unit. Okay, as well as speed they given n is equal to 2800 rpm, revolution per minute. Okay, so these are the data. Along with that, one more data given, C by R ratio they given, C by R ratio, that is 0.0015. So we want clearance. So 0.0015 into R already we know that 0.0015 into R is 0.2023. So that gives radial clearance is approximately or exactly 3.45 10 raised to minus 5 meter. It is in terms of meter. They give. Okay. By the use of clearance by radius, we got the value of C. So by using these data, so you have to find out the one by one unknown quantities. Okay. First, frictional force. We know the frictional force from data handbook. From handbook. Equation: frictional force is equal to 4 pi square r square n dash L by mu by C. Okay. So frictional force is equal to, by substituting all the values, we know that R value, we know that n dash means here n dash is equal to n by 60 RPS. Okay, n we already know that. So substitute mu is also given, L is also given, C is also given. By substituting all the values, we got the value F is equal to 1565 Newton. That is the frictional force. So frictional torque, we want torque, that is F into R. Already we have the F value, frictional force 15.65 Newton. R, we already have the R value. Okay, by multiplying that, we got the value of 0.36 Newton meter. Okay, and the last one, power loss or coefficient of friction, small f, is equal to frictional force divided by operating load. So frictional force we have 65 divided by 820. So it gives the coefficient of friction, which is in terms of 0.019, which is unitless. And the last one, power loss. We have the equation power loss F into U, or we directly take the equation of power from the data handbook. F we already have the value. U means it's a U means 2 pi R, 2 pi n by 60, 2 pi R n by 60. Okay, we have the value of R, we have the value of n. So we got the value of U, that is meter per second. That value you have to substitute here. So finally power loss, it is in terms of watt, 0.15 watt, okay, or 105 kilowatt. Okay, first one we got the frictional force. From the frictional force, first one torque, second one frictional coefficient of friction, third one power loss. By using these data as well as some of the equations from the data handbook, we solve the values. We find out the unknown values like frictional force, torque, coefficient of friction, as well as power loss in lightly loaded bearing. In the problem itself, they given that it is a lightly loaded bearing. Okay. And next come to the second problem. A full journal bearing as the following specification. A full journal bearing as the following specification, like journal diameter 70 mm, bearing length 56 mm, radial clearance 0.05, 6 mm, that is 56 mu, the given clearance. Okay, microns, in terms of microns, that mm converted into meter, that meter gives the microns. Okay, journal speed 22,000 rpm, radial load 10 kg, and power loss of the bearing is 3.8. Here they given power loss. By using power loss, we have to find out the other unknown quantities like viscosity, mu we have to find out, Next, coefficient of friction we have to find out, and frictional force as well as torque. Here also same thing. It is belongs to the same lightly loaded bearing, because you here you can observe that in the lightly loaded bearing, okay, in the lightly loaded bearing, the speed is always high and the load is always low. That's why it is called a lightly loaded bearing. Okay, speed is very high and load is very low. So here you just write down the data given. What are the data given? Okay, first data, that is here, diameter they given, diameter 76 mm. We want radius means 76 by 2 into 10 raised to minus 3 meter. Next, length they given, length 56, 10 raised to minus 3, they given in terms of mm, here meter. Next r, next c is given directly, clearance, so it is 56, uh, 56 point, they given in terms of mm, they given, uh, so 0.56056 into 10 raised to minus 3 meter, okay, or else 56 micron, that you can write it. Next, speed is given 22,000 rpm. Then w, it is approximately 100 kg f, that you have to find 9.81, so that approximately it is 1000 newton. It's very low. As well as power 3.8 kilowatt. So these are the data given. By using these data from the handbook, first you have to find out the viscosity, coefficient of friction, frictional power loss, frictional torque. Okay, we know that equation of power loss, P is equal to F into U. P value 3.8, we already have the into 10 raised to 3, okay, is equal to F. F is a unknown, okay, uh, and U 2 pi r n by 60. Here r is given, n is given. So substituting that, we will give the value of F directly. F is equal to 41 Newton. Okay. So coefficient of friction F by W, that is 0.041. That is 41 divided by 1000. Okay. Next, we need a torque F into R. So frictional torque F already we have the value, and R we have no. So 41 into R is 76 by 2 into 10 raised to minus 3. So torque is equal to 1.46 Newton meter. Okay, and finally we want the value of mu, so that you can use frictional force F. You can use the frictional force value, no problem. Okay, so that is F is equal to 2 pi 4. F is equal to 4 pi square r square n dash L by mu by C. By substituting all the values, only unknown is mu. We know the value of C, L, N, R and F. So unknown mu is equal to, it gives the value of mu is equal to 2.36 10 raised to minus 3 Pascal second. Okay, in terms of Pascal second, that you have to convert to centipoise. So 2.36 centipoise. It's a viscosity. First one, we got the value of F. By using F, we find the value of coefficient of friction, then torque, then mu. Okay. So these are the very simple problems. They given clear data. By using the data and the handbook, we have the equations, required equations. By using those equations, we can easily solve unknown parameters. Clear? So next important problem is, okay, a lightly loaded journal bearing as a following specification: shaft dia 60 mm, that's a given, bearing length 80 mm, radial load 1 kilonewton, radial clearance C is given, oil 60, temperature SAE 60 at the temperature of 65. So for this, yes, SAE 60 at a temperature of 65, it gives the value of mu. So mu is we have to use from the data handbook. Then coefficient of friction of the bearing under the conditions was found. This is a small f. Okay, determine speed n you have to find out, and power loss you have to find out. Okay, so here they given W, shaft dia they given, length is given, and C is given. By using data handbook and find out, first you have to find out the mu value. That is what a graph you have to use, a temperature versus viscosity, absolute viscosity for SAE 10, 20, 30 like this. For a particular temperature, you have to see the viscosity. Okay. This is another easy problem. Next problem, a lightly loaded journal bearing. A lightly loaded journal bearing as a following specification: diameter is given D, bearing length L is given, clearance C is given, speed is given, okay, and load is given. Following power loss of the bearing, that is P, is also given. Find out the viscosity of the oil, that you have to find out the mu, and coefficient of friction at the operating temperature. So these are the datas and these are the unknowns you have to find out. Okay, again use the same equations and solve the problem. Next, another problems here. Here